have probably dragged a pagination component into your React application, wired them up with some API calls, and it works. But have you ever wondered how it works under the hood? What is happening in a database when you click next or page 10? And why some APIs talk about offset while others throw strange, weird cursor string at you? By the end of the video, you should know the two main styles of pagination and when to use each, how it works from database queries all the way to your front-end component, and a few real-world patterns you can copy into your own project today. Let's jump in. So what is pagination? Pagination is basically splitting up your big list into smaller bite-sized chunks. Instead of downloading every blog post, every product, every listing at once, which would be painfully slow, we just fetch a chunk of them at once. And this is important because it reduces the amount of data you send over network. It keeps the page fast and responsive, and it saves your database from doing a ton of extra work. In front-end, you might think of pagination as a UI component with a previous or next button, or load more button, maybe even a infinite scroll. But under the hood, it's about telling the database, like, hey, give me the items from 21 to 30, or hey, give me the next 10 items after this particular one. That's where the two main styles come in. Let's start with easier one to wrap your hand around, offset-based pagination. Think of it like flipping through a magazine. The page 1, you skip nothing, take the first 10 articles, and page 2, skip the first 10, take the next 10. And in database table level, you would like to only return a subset of the data from a particular position. And then in a RESTful API, you might call get API / post limited to 10, offset to 20. The response often comes with a metadata plus your actual data. So the metadata contains the page information like the current page, the page size, the total items, total pages, do we have next page or not? And the actual data is part of the response as well. And then you can use the metadata to render the UI controls, and then the data to actually render the table or whatever the UI is. All right, let's now jump into a concrete example to see how it works from end to end. So I have a front-end application up and running. You can see that the pagination demo, there are 5 items loaded here. It's basically 5 articles. Understanding React server components, building accessible component in React. And when you click the next button, you can see there 5 different items are rendered. And if you click next again, you will have another 5. As I click the button next, you can see there will be a query sending out to the backend. And if I click the previous, you will see there has another query which is exactly the same as the first one. And you may notice that there are 2 parameters basically sending out to the backend. One is a limit, another is offset. And if we click the next again, you will see it has another limit and offset. And also we can see that there is a 20 here, which means the total pages. And if we have 5 items on each page, and then we have 20 pages, so we roughly have 20 times 5, meaning 100 items in the database. So let's go back to the database. So in here, and you can see on the left-hand side, I have a post table. It has ID, title, content, and the correctly add tag. And if we search for the total amount of titles from the post, you can see in the result it has 100 titles. That means we have 100 posts. So if we go to the page again and go to the first page, you can see that it will send the request to limit 5 and offset 0. That means we will get 5 items only, and we don't want to skip anything. We'll get the first 5 items. So it will be exactly like this query. If I mark this offset as 0 and do the query again, you will see it returns the first 5 items, the understanding React server component to building accessible component in React. And that's exactly what happens on the UI. And if we go to the next page, which is offsetting from 5, if we do that here, and then if we run the query again, it will start from TypeScript utility types you should know to introduction to progressive web apps, and it's exactly what happens on the UI. So you can imagine that we will in somewhere have a service or API endpoint that accepting this limit or offset parameter from the front end and translate that into a query we can send to the database, just like what we did manually in here. That's exactly what the API does. If we go to the endpoint, you can see that we are getting the limit and offset parameter from request. And we do the database statement here. We select from the post ordered by, and the limit is that number, which is limit, and offset. And once we have that data, we'll put that data into the rows, and we will add the metadata as well. We do some basic calculation like which page we are in, and do we have any leftovers. And then as part of the response, we will prepare the metadata and the data itself and convert them into a JSON. And then we return that as a whole JSON object to the front end. So the UI can use that to render. And if we go to the UI component, and in offset pagination, we have a user effect block, which will send out whenever the page change. And that will send out to the offset endpoint. The limit will be 5, and the offset will be the state page times 5, which means how many items we want to skip. And then as we have that post, which will be the response from the endpoint, and we just run that as a normal list in React. And we will have some buttons. We disable the button, like if there is no previous pages, we just disable it. If there is no more next pages, we will disable the next button. And we will render what the current page is and what the total pages. This information are all from the metadata as part of the response. This is exactly how the offset-based pagination works. If you have a small to medium sized dataset, it's perfect. You can simply use 2 parameters to control the pagination. Now let's see the pros and cons of this approach. So the benefit of this approach is that it's super simple to implement, and also it's very easy to jump into any particular page. You give it a number like number 10 or number 7, it can go to that page immediately. Well, there are some drawbacks though. It could be very slow for large offsets. The database need to scan all the rows, so it will be significantly slow if the dataset is large. And I can miss or duplicate items if new items are added while you are paging. So it is perfect for small to medium datasets like admin page for dashboards, or some kind of report that has a summary and doesn't change often. But it's not very great for infinite feeds. And another style of pagination is cursor-based pagination. It's also called keyset pagination. This one works more like using a bookmark in novel. You don't say page 3, you say continue after this specific chapter or bookmark I last read. So in Circle, it will be something like select ID, title, correct add from the post, where the correct add less than a particular timestamp, and we order that timestamp descending and then give it a limit. So you will always provide a timestamp for the query to work. So the timestamp here plays the cursor role. So as it changes, you can always shifting or sliding to the next 10 items. And similarly, you will have an API to talk to this database, and then you get the response to the front end. So for cursor-based pagination, it's slightly different because we need something to play the cursor role in the mechanism. So initially, we want to get the first page, maybe 5 items or 10 items, and we can execute that. And we want to get the correct add field from the table. So we execute this one. So with this query, we get the first 5 items. So we'll use this correct add from the last item here and add a while statement and making sure the value is used here. If we run this query, we'll get the 6 to 10. And again, if we want to go to the next page, we just copy the last value from the tens and make sure we are putting the where statement in here. And then we will run the query again. It will get the 11th to 15th. And that's exactly why it's called a cursor, because we are using this as a bookmark to shift to the next page. So now we can always go to the next page. But how can we go to the previous page? You might imagine that we can use the cricket add value from the very first item of the subset. That's correct. We can use that. For example, if we want to go to the 6 to 10, we will use this cricket add. We can just copy this one in here and just comment this out. And we want to make sure that it's greater than the first value from the subset here, which is 915. And then because the subset will be larger than 5, and we want to make sure the order is ascending. So now if we run this one, we will get the 6 to 10, but the order is kind of reversed. Before we return to the front end, we will need to reverse that order. But the dataset is correct, with just the order is incorrect. But normally it's just one page. Maybe it's 10 or 20 items at most. Should be not a problem. We have this like previous or next functionality with the cursor-based pagination, but we don't have the ability to go to a particular page number, let's say page 5. We cannot do that with the cursor-based pagination. And on the front end, if we go to our code, I have a cursor-based pagination component. So basically we'll set a cursor to a string and then pass that as part of the query parameter. And then there will be API to translating this cursor to something that database can understand. And then we can render the UI correspondingly. So now if we go to here, we change this to cursor-based pagination. And on the UI, you can see that we have a next button. And if we clean this network from here, if we click here, you can see it has fetched the next 5 items. And if we click again, it will get the next 5. And if we look at the cursor here, it's not exactly readable. It's base 64 encoded already. And if we copy this one and we decode it to something we can read, you can see that is a timestamp. That's a great way to hide the internal implementation details. And in the backend, you can imagine that we will have a cursor endpoint that will decode the cursor. And then we will use that value to prepare the database query. We will select all elements from post where the datetime is less than the one passed in from the front-end query. After we have that everything, we will encode the cursor again and make sure we are using the correct add from the last item in the rows, which is from database. And then we just return the rows and we put the next cursor to the front end so it can use that for the next query. And there is one more type of pagination, which is infinite loading. It's very common for websites like Pinterest. It has many posts already. And if you scroll, it will load more. And if you scroll, it will even load more. And also, if you go to the dribble, if you scroll fast enough, you can see loading more here. At some point, it stopped and asks you to manually click the load more work, which is a trigger that will loading more items and then stop, and then you will need to click again. And this kind of UI is called infinite pagination, which is a variation of the cursor-based pagination. Only the UI is different, but under the hood, the mechanism, the cursor is still the same. So normally, as part of the metadata, we will add a do we have more or has more pages or has next as part of the metadata. And on the UI, we'll use the intersection observer or some similar mechanism to detect if we want to fetch more. And the query will be exactly the same. And the only difference is from the UI side. We just need to remember the next cursor as we scroll, or when we scroll up, if we have the virtualization enabled, we will need to remember the previous cursor as well as we scroll up. And I have already made a video on the infinite scrolling with pagination before, so if you haven't yet, check it out and try to apply the pagination we learned in this video with that previous video. And there are definitely some important cons for this approach as well. So firstly, it's very fast for large datasets, and secondly, you always get stable results even when the new data is added because it's based on the cursor. For the cons, you can now jump into a particular page, let's say page 50. You cannot do that because we don't have such parameter in the query. And also it's slightly more complicated to implement and handle on the front end because you need to prepare the next cursor, previous cursor, things like that. And in the example, we have seen that we are using the timestamp as the cursor. You might be wondering why we are not just using the ID as a cursor. Sometimes you can. Corrected add is more natural and works well across distributed systems. You can even combine them together, corrected add plus ID as a cursor. And also in most real APIs, the cursor isn't a raw timestamp. It's usually a basic for string, something like this. This hides the internal logic and prevent tampering. So your API might look like this, and it will return the data plus the next cursor. Please also note that there's no universal way to format pagination metadata. So for example, GitHub RESTful API put the pagination links in HTTP headers. When the data has pagination, you will get the response in the header. In the link header, it has like some URL, page equals and the relation is next. Well, on the other hand, Atlassian Jira API includes the metadata in JSON response as part of the actual data. The key takeaway here is whatever you choose, make sure your front end gets enough information to know where it is, whether there's more, and how to get the more. The full flow of pagination. So here is how all of them fit together. So in front end, in the component, when you click the button, you will prepare the parameter for a RESTful API call. For example, the API posts, and then you put that in a query string. It's a current page or next page, the limit, like how many items do you want to render on the page. And then in the server side, there is an API endpoint getting this parameter and prepare that as a SQL statement, and then send to the database, get the data, and prepare that as a JSON format, and then respond to the front end. And then in front end again, you will get the data and prepare that as a normal RESTful call, and you render the data as you get the result. And then you can use the metadata to prepare your next query and bound this event handler to the buttons. So backend format the rows into JSON, including the metadata or cursors sent in the back. Frontend renders the post and store any cursor or page info for the next request. So pagination isn't just a pretty UI component. It's a convention between your front end, your API, and your database. Offset pagination is like flipping through a magazine, simple and direct. While cursor pagination is like leaving a bookmark. It's faster, it's more stable, but a little bit more complicated to implement. And now next time you drop in a pagination component into a UI, you will know exactly what is happening behind the scenes and how to choose the right style for your app. Thanks for watching, and I will see you in the next one.